Hello, everyone. This is Chris Caplice, and this is the SC2X second live event. And I'm here with Steve Ellet, who's the VP of Supply Chain Network Design, or Network Design at Chainalytics. And we're going to talk for a little bit about, I have some questions for him about some of the things that he's done in his career. He's spent the last 20 years pretty much working on network design, so I know no one who's done more of these engagements than Steve. And I'll let him introduce himself in a second. But let me just give you the lay of the land. We're going to talk for about 15, 20 minutes. At the same time, you should be able to enter in questions using Slido. So you should do Slido, SLIDO.com. It'll take you there, and the code for this is SC2X, and you'll be able to see polling questions that we put out, and it's also the way for you to enter in questions that you have. So if you have any questions for myself or Steve or Sergio or Arthur or anyone here, just enter that in, and we'll try to get to those, and we'll let you vote on those. So as questions come in, I'll advance them out so everyone sees them, and you can vote on which question you want to see first. So we'll try to answer your questions starting in about 20 minutes, but I'll start out asking Steve some questions first.
Thanks.
So first, Steve, tell us a little bit about yourself.
Absolutely. Well, appreciate the invitation. Very honored to be here. So I lead Chainalytics supply chain design practice, and I've actually been doing supply chain design work for 25 years.
Since you were in high school.
Hard to believe. Yeah, hard to believe. Middle school was tough. So it's I thought about the other day. I was actually doing this. I started out doing this kind of work in the cement industry while I was actually in college, undergrad. I was in school for industrial engineering at Georgia Tech. I started out working while I was in school and just after school for a cement manufacturer, and I was doing supply chain design work. They gave me the opportunity to build some models and some early tools. It was actually a tool called What's Best by Lindo that you guys might be familiar with.
We still use that.
Yeah, exactly. Yeah. It's still around. That's where I started. So it's and from there just moved into some other things. But went from there. I met some folks at a software company called Intertrans Logistics Solutions, and there was a product that they brought to market called Supply Chain Strategist. And I joined that firm, and I was in consulting around that product for a while. So I was helping companies use it and learn it and doing some training and that sort of thing. And then
were they based in Toronto?
They were based in Toronto, but the development office is here.
Was here in Cambridge, about 2 blocks from here.
That's right. Right. That's right. So it was very, very nearby. And so I had some good exposure early on. Matter of fact, in my Georgia Tech days, one of my early mentors, Don Ratliff, was one of my professors who was the founder of Caplice Logistics, who was another early kind of pioneer in the desktop optimization space. So I went into software. I was in consulting for a while. Then I was the product manager of their product called Supply Chain Strategist for a number of years. Left there, and Chainalytics started up at the end of 01. I joined in very early 02, and have been at Chainalytics ever since, doing consulting work for clients. We use commercial software to do that work, and more recently, the last 5-6 years, I've been leading the supply chain design practice. So that's kind of where I came from and how.
So you've done engagements both as a software company where you own the tools, and you've also done it as a consultancy.
Right.
Is there any differences, or what are the differences or similarities between those kind of engagements?
I think it's a little bit different. I mean, I think that the software companies certainly have a little bit more bent to training and getting users up and running. I think in a consulting firm, our focus is more on the answers. Let's get to a recommendation. Let's take, the 12, 14, 16 weeks and take it from raw data all the way through the process to get to a recommendation. I think most of the software companies, even still today, I mean, the focus of software companies consulting is getting that company up to speed, which we do some of that too. But generally, we're more in the mode of getting to a recommendation and a set of answers.
Yeah. Which do you prefer?
I think it's actually more rewarding to see the whole thing end to end and to help build it from data, get the questions that they want answered through data, through building models and getting all the way to an answer. I think although the software, when I was product manager, that was pretty rewarding. That was a lot of fun. We did some neat design work in the tools, and so I did find that the software development and software design part.
So let's talk about that for a second. So I don't know if people watching it know what a product manager does in a software company. Can you describe that? Because that might be a role that people might be interested in.
Yeah, it's great, actually. It's a nice intersection of the business requirements and the user requirements and the technology. So I wasn't the one writing code, but I was the one who understood the space and what the requirements were of the users and the customers. And we would translate that into the needs of the product. So how do you design it? What do we need to do? Prioritize the releases, prioritize the next things that we should put in. And then we had a team of product engineers that would then translate that into kind of pseudocode, and then developers would actually do the development.
Which did you find more challenging, working with customers to get the requirements turned into something, or working with developers, convincing them of what the customers want?
Boy, the developers were great. They really were back in those days. It was both were a lot of fun. Actually, I really enjoyed both sides. So it was a really good mix of interacting with customers, understanding the requirements, and going into the hardcore data model and technical side, and and also just thinking about the user interface. How do you make something that's intuitive? Because that's a big part of it too. Is there's a lot of software out there that is less than intuitive. And that's a big challenge. What would a user expect? What's weird? What would make sense? What's logical?
When I was doing this, I found it almost like you're translating, because having a developer talk to a customer was never worked out, right? They speak different languages, have different worldviews. So you kind of have to wear a different hat when you talk and bridge between the two.
Absolutely.
Yeah. But now you're Chainalytics, which is software agnostic, right? You don't develop software anymore. So tell us a little bit about Chainalytics.
So Chainalytics is a consulting firm. We focus, I think there may be a slide that has a company overview on it, but we focus in a few different practice areas. We're about 200 people. We started out focused exclusively actually on supply chain design, and we recognized the need to branch out from there. And we've gone into transportation, inventory planning, operations and warehouse layout and design, packaging optimization, inventory planning, several different practice areas now. Our roots are in supply chain design. That's what we started the firm to do. And that's still one of our largest practice areas today. We've got about 200 people overall. About 40 of us are focused on supply chain design. And it's been good growth. We've grown from 2 or 3 people at the end of 2001, early 2002 to about 200 overall today. And we've got offices around the world, 3 in North America, 3 in Europe, and 3 in Asia Pacific.
That's great. Now, is your team, you're running the network design team, are they all in Atlanta, or is your team dispersed as well?
Absolutely dispersed. We've got a handful in Europe, a handful in Asia Pacific. We've got a number in Atlanta. We also have folks remote office and in our other offices around the United States. So it's pretty global. Yeah. Okay.
So how many engagements do you think you've run or supervised? How many networks?
Just personally, or
that your team has you've supervised
our team? Yeah, that's a good question. I mean, we probably at this point are doing about 40 large scale a year, and that's probably been growing over time. So, gosh, we're about 40 a year at this point.
You don't keep track of it. You don't have a little tick mark behind your desk, the number of engagements you've run.
No,
get 1,000. You get
now I need
get a chair or something. No,
a gold watch.
So, what do you see looking at all these engagements that you've run, because they're essentially kind of doing the same thing? Where do you put facilities? How do you flow product? What have you found to be the key drivers of success of an engagement or of failure on the other side?
Sure. I think the biggest thing to think about when we talk about success is what's the criteria for success. And I think of it, and our team thinks of it as confidence. The whole idea of doing this work is to build confidence in the answers and the recommendations. And to do that, you've got to build confidence in the data that goes in, the models themselves, the people, the team. You've got to understand the business, because at the end of the day, you really have to generate confidence in the client organization and the client executive team and their whole team, so that they're willing and able to implement the results. Because this is a bit different than a lot of, say, optimization work. Like think of a routing application. Like a UPS driver gets in the truck in the morning, and he's got his route that was generated by an algorithm, overnight, and he gets it. And that algorithm wasn't probably checked or even seen by a person. Maybe somebody looked over it, but generally that is implemented immediately. They go and they do it right then. What we're talking about doing is strategic network design. So we're looking at infrastructure kinds of questions. How many plants should there be? Where should they be? What do I make where? How many warehouses should there be? And just infrastructure kinds of questions. And those don't go right to implementation. They have to go through a person, a set of executives, a set of leaders that have to believe it and buy into it and become convinced to do it and to spend money. So confidence and credibility is the whole thing.
But you have it's even more complicated, because you're dealing in the future. So back to your routing example, the data that's fed in is actual data. I have this delivery, and they find the best with known data. You're doing something. What is your typical time frame? 5, 10,
usually
15
you're looking
years?
out 3 to 5 years. And the limiting factor not always, sometimes it's further, but the limiting factor tends to be a company's ability to forecast their demand and their confidence level in their demand. If you start modeling out 10 or 15 years and you put some models in front of executives, they don't believe those numbers. Their horizon is much shorter than that. It tends to be 3 to 5 is about where most of it falls.
Okay, so do you find that that's one of the biggest things you have to discuss, the having faith in your estimates? Because everything you're doing, you have estimates of cost, estimates of volume, all those kind of things.
Yeah, so I think there's really two kinds of data that you got to have confidence in. One is historical data. So we gather very detailed transaction level data, so things like order history and shipment history and production history. And so usually the confidence in that is high. Sometimes it's too high. Sometimes there's overconfidence and we have great data, and sometimes we find out that it's not that great. But that data usually has pretty high confidence level in it. And so most of what we do is based upon that data, and then we can take that and extrapolate it out to the future. Other data, we call it design data, which is data that didn't exist historically. So what would a new warehouse cost in Topeka? Or what would a new transportation lane cost between their plant and the new potential DC in Topeka? Or those kind of costs. We call that design data. And that's a big part of what we do. That's a big part of the confidence building as well. And one of the big challenges is getting that data right and unbiased. So think about this example. If you built a model of your current network, and you populated the whole model with your actual transportation costs. Let's say you put every lane, you know what every cost is, and you put it in there. And then you needed to populate the new lanes that you don't ship on today. And one idea would be to call a carrier and say, hey, what would you charge me to ship on this lane? And you would get, potentially, if they would even respond, you would get a rack rate. You would just get a walk-up type rate. And you would put that in the model, and it wouldn't be on a level playing field with your existing rates. And so
it wouldn't favor the new lane. So everyone make sure to know what a rack rate is. It's kind of the retail price. It's the price with no
non-negotiated. Exactly. So if you populate those potential new lanes with the non-negotiated rates and you push the optimization button, it's simply going to reinforce the current state. You're going to get results that say, keep doing what you're doing. Do exactly what you're doing now. And everybody gets a pat on the back. Hey, our network's already great. We're perfect. The problem is that you've not fairly compared all the new lanes. And so that's a big part of our work, is getting that those estimators, whether it's for freight or for warehousing, other costs, fair and unbiased, so that we're really testing it.
I'm surprised does it typically go that way, that the new things come in as more expensive, or they come as underpriced, where people say, oh, we'll save something, we'll get better deals, because then that would favor the new solution?
I think it's more typical that they don't know in freight. I think it's more typical they would go out to a carrier, and a carrier, if they, like I said, if they would even respond, they're just going to give the retail or rack rate. And so I think in a freight perspective, it's likely to be overstated. And so, in warehousing, it could vary. You might poll your warehouse person and say, hey, what would a warehouse cost over here? And then you don't know. Then you might have bias, you might not, and you just don't know. So we've done a few things to combat that. I mean, I think one of the things you're familiar with, we developed this Freight Market Intelligence Consortium. We call it the FMIC. Chris has been instrumental since its beginning. But basically it's a consortium of shippers. There's about 150 members in North America, and they give us their actual transportation spend data multiple times a year. And we take all that data, like shipment by shipment level data of what actually happened, and we put it in a big econometric model, a big regression model. And we can then predict what the transportation costs are actually from anywhere to anywhere across North America for the North American one. We do it in Europe and some other regions as well. But the point is that then you can actually get an unbiased view of what the transportation costs are for lanes that you don't operate today.
Now, when you use that, if someone has existing rates on some lanes, do you use their existing rates and then the FMIC rates on other lanes, or do you use FMIC across the board?
So what we do is we take a sampling of lanes, and we see what their position to market is.
Right.
So if they're 5% below market, for example, below what the FMIC market rate is, then we apply that 5% rule everywhere, and then we use the FMIC lanes everywhere to make sure that it's unbiased. Now, some companies might buy transportation, regionally, and you might have a different discount in a certain region versus another. We take that into account, and obviously different modes, there might be a different factor for dry van versus flatbed versus refrigerated, but we'll get kind of specific to it. But we prefer, I think it's best and it's at least biased to use the FMIC rates across the board.
That makes sense, because it's apples to apples.
Exactly.
So we talked a little bit about the technology, talked about the data, the math underlying. Everyone who's taken the course now, hopefully you've gotten very comfortable using mixed interlinear programs, because at the heart of it, that's really every software. It's still using a mixed interlinear program. And then there's the people. Which do you think is the most the hardest to manage? Which thing leads to the most difficulty? Is it the data, the mathematical optimization, the software, the people, or something else?
It's the people, but it's you think about work that we do, we tend to work in pretty large, complex organizations. And so what happens is that you need a lot of people cross-functionally to participate in this process, because it's not just something that affects transportation or warehousing or manufacturing. It affects finance, it affects customer service, it affects sales, it affects the future of the company. And so you really need a good cross-section of people. So even if it's one business unit in one geography, that's still a handful of people.
Right.
And then you take a complex business that has multiple business units and multiple geographies, and there might be a finance person or a freight transportation person for each geography and each business unit. And all of a sudden, the number of people you interact with starts spiking. And keeping them all on board and continuing to build that confidence, like I talked about, that becomes hard. That's the challenge, is keeping all those people in lockstep, on board, and believing what we're doing.
So how did you learn that? Because your background was, you went to Georgia Tech, right?
I did.
Industrial math, and I'm sure you didn't take any courses on change management. So how did you develop that skill? Because that's something that we don't teach as much. We talk about it. How did you develop that? And is that something you just naturally were born with?
That's a good question. That's something that we've evolved over time. I mean, I think, to be transparent, I mean, most of us at Chainalytics started out, and our core background is optimization and math and things like that. But we have some folks from, broader consulting firms that have some project management experience. And I think, but it sort of has been on the job training over the years. And I think when we started out, most of the projects that we did tended to be, typically we're on the smaller scale, one business unit or two within a company, and project management was less critical. Now, many of our projects are global. Many of them are multi, business units, and you might have a client that wants to bring 50 people to a kickoff meeting, and it's a very different situation. And you really have to take in, treat seriously the project management aspects of it.
So of those four things, over the last 20 years you've been doing this, what's changed? Have people gotten smarter, not less smart? Has that been easier? The math, the data, what has changed over the last 20 years in the engagements that you've run?
Yeah, I think a lot.
And before you respond back, I just want to remind everyone, you can enter in questions using Slido.
Yeah.
Just enter that in, and I will moderate and push those out. And we have a poll out there as well that you can participate in. I just wanted to see how much experience everyone who's in the audience, how much they've had in terms of engagement. And it looks about not much. Well, most people have not, which is good. That's why we're here. Okay.
So lots of things have changed. I mean, I think clearly Moore's law is real. Like, computers have gotten better. Software has gotten better. The optimization engines themselves that underlie the software have gotten better. And so we're building bigger and bigger models all the time.
Is that the optimization or the ability of the database to handle it?
It's both. It's both. I was talking more about the optimization, but it really is the data systems too. I was going to mention that as well. It's the data systems are getting better. Everything we did 20 years ago is sort of Microsoft Access. Now we're using SQL and Tableau and Python and different, Alteryx and Data Guru and things like that are much more savvy in terms of data manipulation. So the tools to manipulate data are definitely getting better. The systems to house that data, and just the quality of data science in general, like the people coming in and joining the team have more data backgrounds than we did, certainly than I did, and that any of us did when we started doing this work. But it's good because there's a lot more data too. So we're dealing with larger data sets.
Right.
I think that's some things that have changed. Some other things that have changed is the frequency.
Frequency
of doing this work.
Doing the engagement.
I think that when I started out, it was really common. I think I have a slide on this. I believe that it's
give us slide.
It might be slide 3 if I look at the not that one, the next one. Yeah. So there's this is kind of what things looked like on the left side of this chart when we first started doing this work. It was common for this work to be done maybe every 2 or 3 years. And what you would do is you just recognize, I have a need for supply chain design, something's out of alignment. Let's hire a consulting firm, let's get some software, let's do a big data collection effort, and let's just do this large scale effort. And then you get to an answer, and then you spend the next 2 or 3 years implementing that answer and kind of living with that network. And so you got to the point where you just had to do it again. And then 2 or 3 years, you do it again. You keep repeating, and it's that cycle that's on that left graph there that's what it looked like. Big spike, flat, big spike, flat.
So every time you did that, it's a massive data collection.
It's a big data collection. It's a big effort. It's a big deal. And you don't really have any way to deal with questions that come up in the meantime.
Right.
You don't have an ongoing model. And so your network kind of atrophies. That's what the bottom part of that, the lower left part of that graph shows. You're atrophying away from optimal the whole time. And 20 years ago, or even 15 or 10, like that was the way to do it. Everybody just did it that way. Now what we're seeing is the frequency is increasing. Like there's a need to do it on a more continuous basis because some of the key inputs are changing, right? Customer service expectations are changing. the world is changing. Fuel costs might change, freight costs might change. Things like, how do I not get Amazon, or different customer service expectations are a big driver. Mergers and acquisitions may come up. So the idea is now much more about, how do I build a model once there's that spike, but then how do I keep it going? More of an inertia kind of.
Some of the decisions aren't you don't change every year. You're not going to suddenly move a manufacturing plant. So do you find that when you do it more frequently, do you have a constrained set of decision variables and changes that you can make?
There are certain things we would refer to more as different planning horizons for different kinds of decisions. So if you might have a longer planning horizon for an open close decision on a plant, and a shorter planning horizon on a different accruing change on a line, for example. And so when we do this, when we set up a model to be done, let's say quarterly, for a year, certain decisions you're going to make every quarter, and maybe once a year you plan to open things up more broadly and look at open close decisions or restructuring decisions. But you never know. In the middle of that year, merger and acquisition target might come up, where you need to reopen everything. And so you've got a single model that's supporting some of those different kinds of decisions. And so at any point, you could take some of the constraints off and answer some of the big strategic questions too.
Now, so we teach in this course mainly mixed integer linear programming to come up with a deterministic solution. But we talk a little bit about stochasticity and randomness and the demand and other things. But we've taught in previous courses SE0X simulation. So how do you handle, or how does Chain handle variability? Because you want to do some kind of sensitivity analysis. You're not going to be exact on the demand. How do you approach that?
Yeah, I think there's a few different things we do. One is pure sensitivity testing, meaning just changing some of the variables. Once you narrow down to a set of scenarios that start to make sense, changing some of the key variables, some of the key inputs, and seeing if your solution is still robust is one way to do it, right? So let me get to an answer. Okay, that answer is 8 warehouses. Now, how robust is that if I crank fuel up by 10 or 15%? What if I put transportation costs down 20%? What about labor? What about demand? And I can test it. And the idea, of course, is to find a network that's robust under a wide variety of those conditions. And usually that's possible with that sensitivity testing. Sometimes we do get into simulation. In simulation, we can take the result of an optimization, a resulting network, and put it in a simulation.
And see how, like acid tested, see how well it performs?
Exactly. You can set some initial conditions, opening inventory levels. It requires a lot more data, because you've got to now know not just what the discrete number is, but you've got to know probability distributions around some of the key variables like demand, like lead times, and things like that. So it takes more time and more effort to do it. But you can do a simulation that shows how robust a particular answer is. And we do that from time to time. It's not what we do every time, and it's kind of the exception, but it is a way to do it. I think the other thing that answers some of the uncertainty is doing it more frequently itself. Like if you're going to make a plan that has to exist for 3 years, that inherently has more risk than a plan that you are able to refresh every quarter or every month or at some more frequent interval.
Because you can respond now, you can be flexible.
And some ways companies are doing that is building internal teams to do that on an ongoing basis, and we help companies build internal teams. In some ways, some companies have chosen to outsource it to us. We have an offering we call Managed Analytical Services, where we actually become the outsourcing partner to continue to do that kind of work.
Because that's one of the big problems that I know from companies' perspective, these big bang every 3-year kind of engagements, they couldn't do them in-house because you can't keep someone there that you only use every 3 years.
That's
if someone likes to do that stuff and they only get to do it every 3 years, they kind of go away.
Absolutely.
So what have you seen as the shift? Have you seen more going in-house or more going, so there's 3 categories, right? Pure in-house, pure, outsourced, and then this kind of mixed model that you see.
There's a mixed model. I think what happens is very, very large companies that can justify and invest significantly in a large team, that they can take it in-house successfully. And I think we've seen just the data over the years that you really need, when you design a team, to think about its longevity and its sustainability over time. And some of the things that affect that are, how many people do you have? Do you have critical mass? Because those people that you pick to do that work, they tend to be pretty good. They tend to be good at a lot of things, well-versed in different things, and they get pulled in a lot of directions. And so if you've got too small a team, you've got 3 or 4 people, let's say, let's say that's on the small scale, and 2 of those people get promoted or they leave or something, well, then you've got 2 left, and that's really fragile. And then if it's hard to backfill. So internal teams of less than 3 or 4 or so people tend to be really fragile. Those people are going to potentially leave or get promoted. They'll do good work maybe for a year or 2, but teams larger than that, and some of the teams we work with at big customers might have 15 people. Then they've got career path and mentoring and and true sustainability. Like, I don't mean sustainability from a
Green
greenhouse
perspective,
gas perspective, but I just mean from a sustaining the team. And those can continue to do good work. And even when those exist, though, we still are asked to come in from time to time when something different happens. So a large merger and acquisition comes in and is different than what that team normally looks at, or something that's different, like reverse logistics, something they don't typically deal with every day. So we still have relationships with these internal teams at large firms. But I'd say that you asked the question about what I see more often. I think it's more common still for companies to do it internally.
The big companies.
Versus outsourcing it on a continuous basis. However, we're seeing a big shift from that. We've launched this managed analytics service that we offer about 2 years ago, and we've seen some significant adoption of that. So I think companies are realizing, hey, this is something that I need to do on an ongoing basis, but keeping it internally is hard.
Right.
And retaining those experts is hard. And if we can put that on a firm like Chainalytics to retain it, then the combined team works pretty well.
Let's talk about your team, though. It isn't because this has changed from being just using what's best and throwing numbers in and pressing a button. It's do you have one role, or do you find that you specialize people on your team? Is someone really good at running the project? Someone's really good at the math. Someone's good at the data. Do you specialize, or do you expect someone to be good at all things? How do you specialize? Or do you try to have the infield?
So I think depending on the level, I think it really dictates the role. So we would have people that have been doing this for 15 or 20 years in a senior advisory role that look after the whole project, right? And then there's a project manager, usually a project manager / lead analyst that designs the models, executes the models, takes care of the overall engagement. And then one or more analysts underneath that tend to be more focused on data, tend to be more focused on results reporting, visualization, those kinds of things. And the team can grow in different dimensions from there. But certain people on the team might have more expertise in a particular industry that might help.
Do you specialize that way, or do you? I mean, are there more similarities between industries than differences, or the other way around?
There's more similarities when we're doing supply chain design. The reality is that if you're doing a supply chain design model, it's pretty similar from one industry to the next. But like we talked about before, building that credibility and that confidence, it certainly does help to have a decent experience and talk their language and use their terminology and be well versed. So if we do have the option of putting somebody in a project that has experience in oil and gas or experience in CPG, that's better.
Right.
That
from the customer's perspective.
From everybody's perspective, but the credibility, exactly. It's better, certainly from the customer perspective, but if the goal is to build credibility and have confidence, it's better that somebody has that background than not.
Do you ever find the case where someone from a different industry comes in and they have an insight? Because sometimes what we've done, industries get siloed and they think a certain way because we do a certain thing, and sometimes they do something different from different industry.
Yeah, we very rarely have people who focus only on an industry. There are people who have more oil and gas or more pharma or more CPG or retail, but no one really, it's not exclusive.
Got it.
And so, no, I think the cross-pollination is important, definitely,
So we have a question, and I encourage you guys to keep putting questions in, and I'll get to those as they come in. VJ asks if there's any advice for people starting a career in supply chain management. For example, which type of positions would be better for building a foundation than others? Well, what's your recommendation? Because you mentor a lot of new hires.
It's funny. I actually think that having an operations background is critical. I actually interviewed a person a couple of years ago, and there was a gap in the resume, and I said, "What happened during this gap?" And the person said, "Well, I just worked in a warehouse." I said, "That's crazy. Like that should be front and center. The fact that you have operations experience, you can talk that language, that you've lived that, is critical. That's important. Like let's not downgrade that. That's huge." So any kind of operations experience, whether it's in a warehouse or managing, I managed a rail fleet early in my career, and some of the
still use those skills every day, don't you?
Well, it helps because you have a good sense of just what when somebody tells me something is 100 tons, I go, "Oh, that's a rail car." You know what I mean? I have this kind of background.
That's interesting,
and I have a kind of a frame of reference of just how things actually are and how they work that you can't just get from doing models. And I would encourage, even when we do a project now, we still always go out and see a facility, tour a site, get a good handle on what things really are in the real world, before we come back to the ivory tower and build the models, right? It's critical to get that hands-on experience. So I would say one thing would be to get operations experience. I think certain roles are going to have more breadth than others. I mean, I think consulting is a good way to get breadth across a lot of industries, but I think those of us that have sort of different kinds of operations background, that's probably one of the things that a student might least expect the answer to be.
Okay, because I know it's easier to learn your math and your operation, well, the math stuff early and eventually learn the people skills. But the practical experience, it's actually easier to do that frontline experience earlier in your career, right? And I know for a lot of companies, we have a lot of students who graduate and they go straight to consulting. And if they want to come back to a company and take a senior VP role, if they don't have that operations experience, if they don't know how to talk to people in a warehouse or on the front line, they're at a disadvantage. And so getting that real experience, I think, is something that's really helpful.
Absolutely.
Yeah. Hey, we have another question. This is from Carolina. In one of my classes at the university, we were discussing cooperation between firms in the same market. Is it more about increasing profits or exchanging information? I don't know if I understand the question.
So in the same market, meaning competitors?
Yes, between firms in the same market. So have you ever done an engagement with two competitors that do a shared facility? Because I know in my transportation experience, I've done this, where you have two competitors, but they do a joint bid for transportation.
So some things that happen in certain industries are things like swaps in cement or chemicals or things like that. If a competitor of yours makes a product near one of your customers and you make a product near one of their customers, you can do a swap and avoid the transportation. So there are those kind of deals, and it's up and up. I mean, those are things that we do model and can model. There's a fine line when you start talking about modeling competitors together, you get into collusion and things like that. So most of the time we don't. I think there's certain things that come close to that would be modeling a whole end-to-end network where you model a customer or you model a supplier. Like that we do pretty routinely.
Oh, you go up and down the supply chain.
Up and down the supply chain. That's pretty common. The other thing that we do that's surprising to people sometimes is that we'll build models of your competitors.
I see.
But without their involvement, right?
Right.
So we take what a company knows about their competitors already through whatever information that they have at their disposal or public information on the internet or something.
No industrial espionage.
No, we don't do any dumpster diving or anything like that. But if our client can tell us, like, here's where our competitors' locations are, or here's where Google says that they are, we can build a model of the competitors, and then we can use that model to say, well, here's what we think the customer service that they're providing is to these markets, or what their landed cost likely is with our freight estimates. And you can actually build models, and you can even ask models, well, what's the lowest cost? Who would be the lowest cost vendor into these markets? And then where would I need to put a facility in order to be the low cost?
That's really interesting. I hadn't thought of that. So you've done all these hundreds, not quite thousands, but hundreds of these engagements. And oftentimes we learn from the bad experiences. So out of all of your engagements, can you name or talk about the biggest disaster that you had, the worst engagement that you had?
I think some of the real challenging ones are when there's just a large organization or a merger and acquisition, for example, where there's just so many stakeholders and they're not all on board with what we're doing. Right? You can imagine in a very large merger and acquisition, if you've just gone through a merger and acquisition, there's a lot of things going on there. There's fear, there's concern about the future, people are worried about their jobs, you don't know who's going to be in charge. Sometimes we're involved in those prior to announcement as well. So we may be in a clean room environment and to be the broker of data between the two sides that aren't allowed to see each other's data yet. Sometimes we're involved just after announcement. But in those situations, there's a lot going on besides just building a model. There's a lot of people and a lot of different factions and people who have different opinions about how it should integrate, how it should not integrate. And so that whole people dynamic is huge. And getting ahead of that, and sometimes, particularly if we're only talking to a small subset of executives at the beginning, you go in with one thought about how this is going to go, and all of a sudden you get into some political scenarios where entire divisions don't want to take part, and so that's probably the most challenging environment we get into. It has nothing to do with modeling, and it has all to do with just people, the internal
politics and politics. People. Is that you're talking from experience then?
I am.
This has happened. This has happened. What happens? Do you have engagements where you just have to pick up the pieces and move forward, or do you walk away to something?
So I mean, in those situations, I don't think we've walked away. I think we've just pushed through it, and what, I think the best way around it is to try to just build up that credibility and just say, look, we're on your side.
Right.
We want to make the best solution for the whole thing. We're trying to put together this optimization program to create the best and strongest company at the end of the day.
Right.
And, but it's just more work and effort, and a different kind of work and effort than you were expecting to go in to do.
So what about the flip side? Can you name an engagement or talk about one where the result or the conclusion was counterintuitive, or something you just really didn't expect? Because a lot of the times you go in, you kind of know what the answer is going to be. At this point, don't you kind of know, because you've done so many hundred of these?
It's funny. I think the most fun ones are when you are wrong or when you don't know. And I've kind of stopped guessing, because it's hard. I mean, sometimes if you stay within one industry, another industry might look similar. But there's one I think about a lot. I was actually at a grocery store with my kids, and we were having this conversation about the difference between different kinds of products that appear to be the same from a consumer standpoint. And the example that we talked about was detergent or a laundry product or bleach or something like that sits on a shelf, and then something like soft drinks. So a soft drink sitting on a shelf and a bottle of detergent or bleach sitting on a shelf, from a consumer standpoint, looks the same. And
it's a plastic container, liquid about the
liquid
same amount.
in it,
it's on a shelf.
Similar price point, might be a little bit different, but not remarkably different. And so I was asking, so what do you think? And I think we have a question.
We have a
here.
polling question.
So go ahead.
Yeah. So we're asking if you have a manufacturer of laundry detergent, a P&G, a Colgate, a Unilever, and then you have a manufacturer of beverages, so a Pepsi, a Coke, any of those, which would have more DCs? Do you think the laundry detergent manufacturer, about the same, or the beverage have more? And so there's a poll for you to take to see which you think would have more.
And this is interesting. We probably should have asked it too, like what degree of difference. But that's so it is interesting. So some people, it's coming in about wow, people are changing their votes. People are changing their votes.
You see, though, we've only had
there's only
people aren't voting. You need to vote.
How can it go from 20 to 0?
Wow, someone changed their vote.
Someone changed their vote.
That was Sergio. Right.
That's good.
Okay, so it looks like we're getting more in now, but it's saying that most people are saying that the detergent manufacturer have fewer DCs. Yeah.
So 80-20. So that's actually right. But what you might not think about is just the severity of the difference. So a company in the let's say bleach or laundry detergent might have typically probably less than 10 in North America, let's say. A large soft drink company would often have more than 400. And that's a very, very different answer. And both of those are mathematically right. Like if you built both of those models and ran them, you would get an answer that was close to those. And so I find it fascinating that the numbers drive that. And there's a lot of things that are going into that. One is the product velocity itself. Just think about how many bottles of Coke you buy versus how many bottles of detergent you buy.
I go through a lot of bleach, Steve.
So velocity is part of it. Part of it is also just the model itself. Right. Soft drink companies typically are a direct store delivery model, DSD. They're delivering directly to the store. So they have to be close. And liquid in a bottle is a very expensive thing to move around, right? It's mostly water. It's heavy. It's expensive. And so that has the effect of pushing you closer to the customer location. And so if the customer location is everywhere, right? Everywhere there's a retail store, naturally you're going to need to have more so you don't drive that far. And some of it is also, and just the counter to that is someone that's making laundry products or bleach or something is typically not doing direct store delivery. They're shipping into the distribution centers of the retailer in typically full truckload quantities. And so that's a cheaper mode of transportation. You can be further away. So the numbers really do add up. If you look even just at things like the fixed costs of the operation, so a bottling plant for soft drink is just a less expensive proposition than a plant that makes detergent or bleach, like a large kind of chemical type plant that makes these things. So there are more bottlers from that standpoint as well. So what's fascinating is if you put all those numbers together and build models, you'll come out with very different solutions for things that appear, to be the same.
Yeah.
So I think that's a neat little example that kind of highlights it. But I think that's the fun part of doing the work is that you let the numbers lead, let the data lead, and the math leads you to something that you may not have thought was intuitive.
Let me ask you something a little more technical, and then people are putting in questions, and I'll get to those in a second. But as you see the questions there, you guys can upvote them or not. So as you decide, if you see a question on there that you like, just upvote it, and I'll start from the most popular ones and work my way down. So we'll get to that. But let me ask you a technical question. One of the things, the points that I make in the lectures that we do is when we do a supply chain network design, it really doesn't look at inventory, safety stock, and all this. And so how do you address that? Because a lot of people, they use the square root rule. If you cut down my DCs, I'm going to have less inventory, and it kind of favors just reducing the number of facilities. How do you deal with that?
Yeah, it's a good question. I don't think I would word it the same way that you did, that we don't consider it. I think almost every project that we do considers it. It's just how we consider it and how much detail we consider it. And safety stock in particular is a hard thing to model. Most of these, as you mentioned earlier, we're doing linear and mixed integer optimization, and a safety stock behavior doesn't really lend itself to a linear relationship or even one that's easily to represent in a mixed integer world. And so it really comes down to how important is the inventory to the questions that we're trying to answer. So there's a whole spectrum of things that we can do. On the easy end of the spectrum would be, as you mentioned, just ignore it, right? If something doesn't matter, if what we're testing isn't going to affect inventory, you could ignore it. That's almost never the case, but it's possible to ignore it. That would be the extreme end of the spectrum. The second step in would be do some just pure textbook calculations for safety stock. Let's run the math, and let's take the demand variability and the other variables that go into the safety stock calculation and just purely calculate it in a spreadsheet or something. The middle of the road is what you described, which is a power curve or a subset of power curve, a square root function. I mean, when we do that, we're a little more advanced than square root. We actually take actual data and do a nonlinear regression to try to figure out what the curve looks like rather than a square root function.
So we talk about that. And so I show how to do that because I follow the same kind of thing where you look at what they actually do in performance and adjust it. Great.
And that is not the end all, right? You could take one step further and actually run a true inventory optimization. And we do that often too.
Okay.
And so then you
do it like sequential. You do the network
iterative.
Iterative. Okay.
Right. So it really just depends on how important the inventory component is to the question that you're answering. And so it is important even if we're talking about a simple number of distribution centers kind of question, how many should you have? Safety stock is important, right? If I stock inventory in one location, I'm going to hold less in general than if I have to spread it out into 10 locations. And so that's true almost in every case. And we need to be able to represent that. Now, do we have to represent it down and make recommendations for this particular SKU and what the inventory policy should be for that SKU? Maybe not. If the answer is just generally how many warehouses should I have and they're all going to be full stocking. In that sense, a square root or maybe a bit better than square root, a more generalized power curve might be sufficient.
Okay.
But in other cases, it's not. If I'm moving around, high tech or high value products or, something where inventory really, really matters, and that's the driving force. And I really do want to know what my stocking policy ought to be at this location, and it's different than that location. Then, and I want to meet this exact service level. I want to hit 98%, service, and I want to set the policy for this. Well, then inventory optimization is a great way to do that. So there's a whole spectrum of choices, and depending on what we're trying to accomplish, we're trying to find the right one.
How detailed you go into different forms of analysis.
Exactly. Yeah.
All right, let me ask some questions from you guys. I'm going to start with a question from Mei Zhang, and I'm starting with Mei because she submitted a problem from practice for SE0X or SE1X, if I'm not mistaken, from her work at Timbuktu, which makes handbags and knapsacks. So her question is, we're just a team of 4 people in our operations department at Timbuktu. I'm surprised how big the teams you mentioned. Do you think it's short-sighted for us to open a DC in a new country just based on the cost savings, or do we need to analyze more? So it's kind of 2 questions in there.
Yeah. So the first question is, you're surprised by the number of people that are doing supply chain design work. Well, when I was using the number of 10 to 15, that's for a very, very large, multinational corporation that's doing this around the world and is basically kind of a mini Chainalytics, inside that company.
Right.
And there are, many of those. I mean, I think that is probably the right size team for what they're doing. Doesn't mean that every team needs to be 10 or 15 people, but I think once you get smaller than a handful, once you get smaller in that 3 to 5 range, it just simply becomes difficult to sustain it.
Yeah.
So no matter what size the company is, right? It's just because you're just then exposed to people's career objectives. And, I think in general, if you're inside a company and you're working on the same model all the time, I do think there's a tendency for people to start looking around thinking, wow, I don't want to be pigeonholed into this role. And so there's also that natural force that pushes people to look outside of that role. Whereas in a consulting firm, we don't have that, right? We're able to give a variety of project work and so keep people interested for 15 or 20
It sounds like
years.
you can progress them through different stages of
Exactly,
of
stages and
engagement.
just a variety of kinds of models. And in a medium-sized company, it's just harder to do that because
Right.
it's harder to keep the people interested in that. They have a career aspirations as well, and often those involve, if they're moving up in an organization, then they're moving out of that modeling role.
Yeah.
Whereas at a place like us or at a large team, you can actually have a career path within that team.
Right.
And that's just something that doesn't exist in a team of, less than 5, let's say. The second part of that question was, should they have more than one DC?
In a low cost, if they find low cost in another country.
I'd be happy to put together a proposal and come in and help answer that.
There you go.
No, I mean, the reality is, like we just talked about, it's very difficult to know because you do really need to study it and look at it. And that's a question we look at all the time is, I'm entering a new market. Should I distribute from my prior market, or should I enter, should have a DC there? And a lot of things go into that. We answer the question all the time about, border crossing. Do I need to have a facility on the other side of the border to ship to it and have stock of inventory there so that my customers are not exposed to the uncertainty of the border crossing? Those kinds of questions are difficult to answer, from a high level description like that, but they're important ones to answer.
Right.
And
right. And in SC3X, we spend more time on global supply chains and what that means, border crossings and different tariffs, tax rates, and things like that.
Yeah.
Let me ask another question from Arthur. How important are your communications materials for conveying concepts to your clients? How do you translate the complex design models to shareable models?
They're critical. I can't overstate how important they are. I mean, that's the whole game, is when we talk about building confidence and credibility with the clients, doing that visualization is critical. And I think I mentioned earlier that visualization tools have gotten a lot better. We're using things like Tableau and other, BI type tools and other data visualization tools. I mean, I think, we're seeing some
sitting in the visualization
pretty
lab.
impressive ones behind us here that might be a little above what we typically do. But it's critical to convey this complex concept of what's going on to the executives that then have enough confidence in it to implement it is the whole game. And so if I look at some of the things that have changed, I mean, that has gotten a lot better. I mean, I think the tools that we use now are significantly easier to use and produce better
than
results.
what's best.
Better than what's best in my, Lotus for DOS spreadsheet. Yes.
Yeah. So here's a question from Francisco. How do you identify a bad network design?
That's interesting. I mean, that's something
Can you look at a network and someone says, here's my network. Do you have a sense you can say, oh man, that sucks?
There certainly are some key metrics you can look at, right? I mean, some of them are you shipping a lot of long distance, small shipment sizes, right? I mean, think about it. You probably have covered this in the class, but just think about how supply chain works. You generally want to push things as far as you can in the largest shipment sizes. And then at the last, as late as possible, make them smaller shipment sizes, right? Zone skipping and pipelines and ships and things like that all work on that principle. And so if you look at a network, that's one of the things you can look at is, we call them light and long. Are there a lot of light, long shipments? Are you shipping LTL 3,000 miles across Europe or across the country? If you are, it's probably a better way to do that.
That's a low-hanging fruit.
There's probably a good indication. I think some companies too, you just sort of know it. They've grown through acquisition over the years, have never really taken a holistic look at the network. And you can just look at a map and say, yeah, there's definitely some opportunity there, and just knowing from experience. But there's some key metrics, and I think there's some just intuition from doing it a lot too.
Okay. Here's a question from Chris. What is a typical engagement like, if there is such a thing? How clear is the business problem, the math and or process problem, the state of the data, buying from internal stakeholders? Could you give a general sense? So what's a typical
project looks like? Sure.
Yeah.
I think in terms of time, usually the low end is somewhere around 10 or 12 weeks, and the high end is somewhere 18, 20 and plus. And we can easily fall outside of that range too, with very, very large projects or very, very small projects. But I think that 10 to 12 to 18 to 20, it's typically in that range. And what it looks like is there's there's understanding the business, right? We need to come in and understand the business, tour facilities, see what's going on. In parallel to that, we're collecting data, the shipment history and order history and production history and those kinds of data sets. We're taking it through a pretty rigorous validation process to make sure it's right and make sure that we're understanding it. And then from that, we build a baseline model of how the network works today, what its what it's doing right now, and we're able to then compare that to actual data. So total transportation costs, total warehousing costs, we should tie out pretty well. And then we decide on what scenarios we're going to run, and we develop the design data that I talked about, which is the new lanes and new warehouses. And then we run a series of optimization runs. Maybe it's 50 or 100 or so, different optimizations and sensitivities. And then the final step is to interpret the results and make recommendations. And all of that is done hand in hand with the client organization. This is not us disappearing, with the data and coming back with the magic answer. It's a very collaborative process, and that's what it typically looks like. And the size of the team, if that was part of the question, the lowest that it would typically be from our side would be about 2.5 or so people. Okay. Maybe somebody who's less than full-time in a senior advisory role, and then 2 full-time people in a lead analyst / project manager and analyst mode. And it can size up from there. I mean, some of the really large ones that are on the other end of the curve would be things like global. If you think about some of the things that make a project bigger, number of business units, number of regions, things that are global, it really is helpful to be smart about what's in scope as well. If you think about, there are problems that are truly global, and there are also supply chains that seem to be global that are not really global.
Right.
I'll pull soft drinks example again.
Okay.
You can go anywhere in the world and get a particular soft drink that's based in Atlanta, right? You can have it anywhere. That doesn't mean it's a global supply chain. It kind of seems like a global supply chain because it's everywhere, but it's really not. Right? It's a multinational supply chain, right? They're not containers of soft drinks, 12 packs of soft drinks in ocean containers being shipped around the world. They don't do that. They make it regionally for some of the same reasons we just talked about. And so that's not a global supply chain, at least the finished good aspect of it isn't. The syrup part might be. But the other end of the spectrum would be truly global, right? Something like high tech, a smartphone or a laptop, chemicals also. It's very common for a chemical company to make, sub-product 1 in Germany, sub-product 2 in Singapore, bring them together in Houston, blend them and make them a product, and then ship it around the world. That's a truly global supply chain. You do need to model the whole thing.
Have you tried to take a company that does have global supply chains as you defined it and try to convince them that maybe they could shift to a local? So it's almost changed to their focus, or do they tend to not change stripes?
I think they tend to not change, because in those 2 examples I gave, right, I mean, with very rare exception, smartphones are made in Shenzhen, right? I think there's some exceptions in Brazil and for some local laws and things, but generally, we're not going to change that. The economics are such that it's just where it's going to be done.
Because what I'm thinking is automotive. Because I know there's some automotive where they have focused factories, and the fact all transmissions are made here. Yeah. All the assemblies are made here versus you shift and have more general. Because one thing I also talk about in the lectures is chaining. So you make sure that a plant is a product or an assembly is made in at least 2 plants, so you have redundancy. And you can move around. So I'm curious if that comes up much in practice.
Automotive is interesting because that one, I did some work. It's been many, many years ago, but if you look at some of the decisions that they make, that they have to make around where to produce a particular car, right? You'll notice that many of the larger vehicles, like SUVs, tend to be made in the United States, even though the parent company is not a U.S. company. There's a lot of forces for that. One, I think the demand tends to be greater for those cars here. The market is here. But transportation costs are also higher for those larger vehicles. You're going to get fewer of them on a ship. I mean, there are some transportation components as well. And tooling up multiple lines to make the same product is a very expensive thing to do. Right. So those are definitely things that we could model. And certainly those decisions are made with these types of models.
Makes sense. Absolutely. So one of the things you mentioned earlier is that the speed of optimization has gotten better, and you can do more runs faster. It's almost a double-edged sword. Do you find, because initially if it took a day to do a run, you do 5 runs and you say, okay, we make a decision. Yeah. Do you find the number of different runs, scenarios, is it just exploding? Or because everyone wants to do a what if? So how has that changed over time?
That's interesting. I think you say it's gotten faster, but we also just make bigger, more complex models to kind of.
So has the runtime stayed constant?
I think in general, yes. But obviously, if you solve the same problem now as you did then, it would be remarkably faster. But then you were making more concessions. You were giving up more, and now you don't have to give up as much. You still have to give up some. There still is room for improvement. I mean, software people out there, don't stop, right? It's important. Like, we still need to make more progress in it, but we've made a lot. If you think about just the shape of Moore's law, that kind of thing, the software is getting better, hardware is getting better.
Right.
I mean, we're taking advantage of it, but we are building more complex models. So we're doing things today that we wouldn't have thought of doing, years and years ago. When we first, if you think about the beginnings of supply chain design, it was called network modeling or network optimization. It almost always referred just to how many warehouses should I have?
Right.
That's still a question we answer, but more often today, the question is, well, how many manufacturing lines should I have? Where should they be, and what should they make?
Right.
I'm using the same kind of modeling tools, same kind of underlying math, but I'm answering a far more complex question. But I'm also answering that warehouse question at the same time, the same problem. So the models have gotten bigger because we're doing more in them. So I wouldn't say that the general trend is that now we can do 100 runs where before we only did 10. There's some of that for the similar size problem, but more often than not, I think we're just taking on more complex.
You can solve a bigger problem. You can solve a more complex problem.
Yeah, that's generally what we do. And that's probably not what everyone does, but that's probably our tendency, is just to put more in there.
We're just about out of time. We have 3 or 4 more minutes. Any last words of advice you want to give our young learners, our students out there?
Yeah. I think what we talked about before of having operations background in this is critical. I think, don't downplay that. I think that is very important. I mean, a lot of us that have been doing this a long time have a background in one industry or another, or working actually, in transportation or in warehousing or having something like that. And that's critical to build that credibility up and the confidence and being able to talk about it. I wouldn't shortcut that. I think that's definitely an important one. And I think some of the things you brought up too, that it is a people business. You can't do this.
You can't just do your models.
You can't do it in the basement, right? I mean, the modeler in the corner model doesn't work that well. If somebody's sitting in a basement with a model, they don't have the credibility. The executives don't know that they're there. The executives don't have confidence in them. And it just doesn't work. You have to be able to convey what you do. And it could be through visualizations like this. It could be just through standing up and talking, but you have to be able to communicate what's going on, because the executives, she doesn't know what's happening in the model, right? You want to get to the end of one of these where the executive at the end of the table looks at her team around that table and looks at transportation and warehousing and finance and says, are we on board? And they want to look, we want them to look back at her and nod and say, yeah, we're on board. So it's that credibility building, and it's, a lot of that credibility is certainly technical, but an awful lot of it is also the people and the process.
So she doesn't ask you about constraints, specific nonlinearities?
Sometimes you got to be ready for anything.
All right. So thanks, Steve. I appreciate it. This was great.
Thank you.
We have more questions that we couldn't get to answer. We'll try to respond to those after the fact, but I have a couple quick announcements from Sergio. Remember, the due date for week 4 grade assignment is May 9th, 1500 UTC. Everything's done on Wednesday at 1500 UTC. And remember, this is different. This is a proctored exam. And the reason why we're making you do this as proctored is because we want you to get used to using a proctored exam, because this is what we use for the CFX when you come through and finish the MicroMasters. So this is just one way to get you comfortable and familiar with it in a low risk environment, because the homework each week is only worth 2.5% of your total grade. You have to use the proctoring software. The instructions are in there. You have 2 hours to do it. So it's a relatively simpler assignment. You get it done in 2 hours, but the real reason we're doing it is to make sure you know how to use the proctoring software and it works on your computer and you understand how it all works, so you're not surprised when you take the CFX and it's all being proctored. Second announcement, a midterm exam opens May 9th, again at 1500 UTC. It's available for 1 week. Once you start, you have 4 hours. It's pretty standard. You guys, should be your 3rd course, so hopefully you're used to this format by now. And this will cover everything in weeks 1, 2, 3, and 4. But what we've discussed today will not be covered. Right? You won't be quizzed on Steve's knowledge.
That's too bad.
So with that, I'll close it out. Again, thank you very much, Steve.
Thank you.
Appreciate
Honored to be here. Appreciate the invitation.
Thanks.